Hello everyone. Let's talk about let's talk about engineering solution to one of the most intricate challenges that we face across many industries today. That is the compliance with GDPR. GDPR stands, as you know, for General Data Protection Regulation, which requires us to ensure that any personally identifiable information is not out in the open, it is not in plain text. The same thing applies to PCI, which means the payment card industry data, anything like credit card numbers, any CVV numbers, those kind of financial information is protected and it is not out there available in plain text. Email addresses, first names, last names, passport numbers, telephone numbers, all these kind of fields come within the purview of GDPR, and these should not be out there in the plain text. If it is, then the organization gets imposed very heavy penalties, and which causes a huge problem. So why is this GDPR compliance such a challenging task in terms of an engineering solution? Come to think of it, in a production environment, in a typical production environment, there could be hundreds of microservices, let's say 300 plus microservices, and each of these microservices would have the request responses, request response structures. There could be tons of fields out there which could be in the realm of this GDPR sensitive data. How do you go about identifying and then further go about adapting these microservices so that at least these fields are not out there in plain text, at least they get masked? One of the straightforward ways is, of course, to go to every single microservice out there and then go ahead and make the change. Look at the field, go ahead and mask it. But imagine how impractical that approach would be, how time consuming it would be, how financially draining it would be, and how much of manpower and testing effort that it would be required. This is the reason why this turns out to be a very intricate challenge. Also, there is the other aspect to it. Let's say you complete this entire exercise. Okay, you spend a year or 2 years and complete this entire exercise. There is always a possibility that GDPR may come in and say there are few more fields I'm adding today, which you have to also take care of. Now again, you have to go through the same strenuous activity to ensure that the sensitive data is now masked. So that's the reason why this approach becomes very impractical to take forward. So what is the solution? How do we go about this particular problem? To discuss this further, let's now refer to my Medium article, and we will go through the approach that is provided in there. This is the Medium article, BankNext case study, GDPR challenges solved with SpringCloudGateway. So let's just take a step back and see what this problem is, which we have already discussed, the business scenario, and let's take a concrete scenario in today's situation, and why this turns out to be a showstopper. So as we said, the organization is faced with complying with GDPR, PII, PCI, which is a massive undertaking. And how do we go about that? The business, of course, it has tight timelines and constraints, and going through every single microservice and adapting it for this is certainly not an option, given that it's a very, very time consuming and very intensive, manpower intensive activity. Let's take a concrete scenario to move forward. So let's say in our case we have core microservices. Let's say one is a payments microservice and one is a customers microservice, and we have a client consumer who calls payments microservice to get the payments information, and customer microservice to get the customer's information. In both these cases, payments, when it responds, it sends data fields which are related to payment. It could send credit card numbers, CVV numbers. These are all GDPR sensitive fields. When viewer service calls the customer service, it could send, the customers will respond with the customer information, which could be customer identifiable information like his email address, his telephone numbers. If the viewer microservice receives this, it has to undertake multiple activities which are mandated by GDPR, and these activities are very, very strenuous, and they are also they also incur quite a bit of expense. Now, if on the other hand, if this consumer or this service does not do that, then it is liable to imposition of heavy penalties, which is a huge problem, and that's a major pain point in our financial industry, in the banking industry, and in general any industry that deals with sensitive data. So what is the solution for this? Before we get into the actual core solution, let's think about what kind of capabilities do we really need to solve this problem. We already have said that going to each individual microservice and fixing it and adapting it is not a practical option. So that's why what we need is something that is centralized, that is configuration driven, so that tomorrow, if there are more applications that are added to our production environment, we don't have to go again to individual services and then make changes there. Instead, we configure this in a centralized environment and have those actions reflected in those microservices also. Thus making us future-proof and giving us that much flexibility. Tomorrow, let's say GDPR introduces new fields, we should be able to add those fields into our configuration and thus take effect, and thus the GDPR actions take effect. For example, in this case, let's say a loan number gets added to the list of fields, so we should be able to go ahead and add it to an externalized configuration, and then that particular field, if it's available in any of the requests or the response that are coming, it should be must, and that is our core requirement to comply with the GDPR compliances. We should also have the flexibility. Let's say there are 300 microservices. It's not required that all 300 microservices fall. Maybe 150 of them fall. So we should have the capability to selectively intercept these microservices and have those only within the purview. Also, one of the most important requirements is that existing microservices, we do not want to affect them in any way. That means we do not want to go ahead and write code in there and then have them built, have them deployed. That will cause a massive undertaking on our side. Also, one of the other important requirement is that whatever solution we develop, it has to be lightweight and it has to be extensible with very, very small latency, if any, added. So with this expectation of the target state, let's see what we can use to achieve this solution. One of the ways, a very effective and practical ways to achieve this is by employing SpringCloudGateway, and we will see why. Why does SpringCloudGateway help? For that, we will just refer to this diagram. Okay. In this diagram, you see what is happening. These are the two core services: the payment service, which is running on 8081, and this is the customer service, which is running on 8082. This is our consumer service, which calls these two services. Now, without SpringCloudGateway, our architecture had our consumer viewer interacting with this, invoking this payment services directly. The response comes with these sensitive data fields, which goes to the viewer service, and then hence the responsibility lies with each of these individual services to handle that. In our approach, what we are recommending is that we put a Spring Cloud Gateway as an intermediate in this architecture instead of our consumer service directly interacting with the core services. And this also brings out a very important best practice pattern where we should not, which states that we should never allow our external services, consumer services, to interact with any of our core services directly. So now that we have introduced this, let's talk about how does this help us and how does this bring in the flexibility that we are looking for. So what happens is, as soon as we introduce this, all the consumer services that we have will be interacting with the interface. For them will be the Spring Cloud service, which will be Spring Cloud Gateway, which is running on 8080. So when they hit Spring Cloud Gateway, they will also be providing the context. So for example, when a viewer wants to access payment services, it will hit 8080, that is Spring Cloud Gateway, and it will provide the context payments aggregator. When it wants to call customer service, it will again hit the Spring Cloud Gateway, that is 8080, and it will provide the context customers aggregator. The advantage that this brings to the table is that tomorrow, let's say payment services is changed from 8081 to something else, or we have another version of payment service, let's say payments-business or payments-advanced service. We don't have to change, we don't have to have all our consumers change that reference URL again, because they will still be calling, they will still be referring to the payment service with this URL that they already have, and we will internally then be routing it to the correct service that we need to. This again, there is nothing new in this. This particular pattern is one of the best practice patterns that has always been recommended. Now, once the request comes to Spring Cloud Gateway, what it does is that it has a configuration that specifies that for a context that comes to me, that is payments gateway, what should I invoke? In this configuration, what we are saying is that when the URL path has payments aggregator, invoke the service that is running on 8081. That means invoke the service running on payments. And after you invoke the service running on payments, you also apply the filter. These filters are predefined filters in Spring Cloud Gateway, which allow you to intercept the request and the response and allow you to perform actions on each and every field of that request and response. Thus, we are in a position now to intercept the response, parse through the response, figure out which those fields are that are of our interest, for example credit card number, and once we figure that out, we can simply replace the value with whatever mask value that we want. Same thing is the case with when the viewer service asks for the customers aggregator, the same process happens. So thus what we have done is that the fields that we are interested in, let's say it's credit card number, first name, last name, and let's say GDPR introduces loan number at a later point, these fields will simply be added to an externalized file. So we will be able to simply add, change or remove fields from there depending based on our requirement, and have this system still running with these changed fields and having this GDPR compliances met. So now just what we have achieved with this approach is that we have achieved this entire GDPR compliance just by applying by using a configuration. We have also made it flexible, we have also made it extensible. Another very important capability that we have gained is that we have achieved this compliance without making any change in these core services. So tomorrow, let's say there are 5 more services that get added, a loan service, a credit card service. You will not need to go ahead and make changes in these individual services to mask the fields. You just have to take the fields that are sensitive and you have to add it to the file that contains a list of sensitive fields. SpringCloudGateway configuration and this filter that you have provided here will simply read the externalized file, match these fields if they are available in the request and the response that is coming from these core services, and it will simply change the values, the real values, to the masked value. It will simply replace it with asterisk, 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 or hash, 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 whatever is the character set that you have mentioned in the configuration. Thus, our viewer service also is not affected. So none of our consumer services, we will not have to impose any restriction or constraint on them due to this. Everything will be handled centralized in our SpringCloudGateway. We will have the flexibility via configuration to add and remove fields for the GDPR compliance. Now let's move forward. Now that we have a solution approach and a practical approach with SpringCloudGateway to achieve this, we will just go through take one step deeper into the details of this. So this is the GitHub repo where I have committed all the applications and the code, a working code that demonstrates this particular approach. You can take a look at that. So this, we have achieved a single and uniform endpoint host for all the microservices. We have externalized the microservices handling with simple Spring Boot routes config. Incoming and outgoing traffic is handled with predefined SpringCloudGateway filters. All these are the points that we just mentioned here. Also, you will notice that the entire process that SpringCloudGateway employs is a non-blocking architecture. Hence, the process it ensures rapid processing and very high throughput. Thus, we have achieved the future-proof flexibility. Tomorrow, let's say you want to add another functionality to this request response transformation. You can simply do that by adding the filter to it. Okay. In terms of code, you will see that in the application YAML, this is how we specify the configuration. In the routes, we will simply say this is the name of the route. We will simply say when the path, that URL contains the path payments aggregator, routed to the service that is running on 8081, which happens to be payments, and for every request and response that is coming, send it to this particular class, mask sensitive response, which is the implementation of the abstract gateway filter factory which SpringCloudGateway provides. And then whatever mechanism, whatever logic that you put in the apply method in there, that logic gets applied to every single field in the request and the response. Thus, you have centralized the whole process. This is the filter that we are talking about. This is the filter that we have written here. It is extending abstract, this is a predefined filter, abstract gateway filter factory, and we simply have to provide the implementations in this apply method. That's it. This is the custom masking that we have written here. So what we are doing here is that for every field that we get in the JSON, so we have full access to the request and response JSON structure, and hence we are able to go to each and every field in there, and we are able to apply whatever custom logic that we want. In this case, what we are doing is, once we identify that the field is actually matching our list of sensitive fields, we will simply go ahead and change the value to the masked characters. This screenshots will give you an idea of what it was before the solution and what we have achieved after the solution. So for example, here, let's take a look at this one here. We are calling, so this is our viewer service. Okay, this viewer service is calling payments. This is calling without the Spring Cloud Gateway. In that case, all this information shows up here in Spring Cloud Gateway through its configuration and filter arrangements makes a call to the core service, that's the payment service, and the response that comes in goes through the filter, and the filter ensures that GDPR compliance gets masked. Same is the case with this one. This one is a direct call to the customer service, the viewer service. If it makes a direct call to the customer service, the data that comes is like this. It's all in plain text, telephone number, email address, etc. But once we have introduced the Spring Cloud Gateway and followed this particular architecture, the viewer service, which is completely abstracted to whatever core service, internal core service. That internal core service will respond with whatever it is responding, with a raw response, which may have the sensitive fields. Once this response comes in the configuration, we have specified that this response should be subjected to a filter, and that filter we already have the mechanism where these fields will be matched. If these fields are of our interest, those fields will simply be replaced with this asterisk. This is the overall mechanism, and this is the conclusion of it. Now, before going to the conclusion, we will run a small demo so that we get an understanding of how this works. Okay, so as is said, which will actually be our client consumer, which will here the payments, the customers, the Spring Cloud Gateway service, and the viewer service. And there is a collection also here, the collection curls that you can use to test the service. Okay, so this README provides all the details that you might need to execute this demo. So to do that, we will simply first thing you will need to clone this applications in your local machine, and once you clone this application, we will simply be launching it one by one and then running the demo. So what we will do is we will simply follow this instruction. So once you clone it, we will first launch the payment service. In this payment service, we will do an mvn clean install to build the application, and then we will do a launch the application. So for that, I will go here. I've already cloned it under a payment processor, so I will go ahead and do an mvn clean install. These are standard processes that we use for our Maven based Spring Boot application. We are simply executing the simple steps here. Okay, so this application is built. I will now attempt to run java minus jar, and that's the jar. All these steps are mentioned in the GitHub README. Thus our application is up. It is running on 8081. Our payments application is running on 8081. Let's start the second application, which is the customers application. These are the two core applications. For that, I will simply go ahead and run. I have already built this application. So this is customers. Our payment application is running, and now our customers application will start up. Yes, so our customer's application is also up and running, and it is up on the port 8082. Okay, now we will start the third application, which is our viewer, which is our consumer, who will be interacting with these two core services. So I have already built this application, so I'm going to launch it. Okay, so this application is also up and running. This application is running on the port 8079. Okay. The fourth application that we have is the Spring Cloud Gateway. For now, we will not launch this application. We will see the result of invoking this payment and customer core services without the Spring Cloud Gateway. We'll see what happens in that case. Okay, for that we will go to, this is the Insomnia, and I will launch here, and then we will see. So this is, I'm hitting the payment service directly. This is a simulation of the viewer service hitting the payment service directly, which means that we don't have so it hits directly, and we will see what is the response that comes. So this is the response that came from the payment aggregator service. It has a bunch of fields which are PCI related, which fall under the GDPR purview, like first name, last name, credit card numbers. All these fields are PCI sensitive fields and PII sensitive fields, and hence we are in gross violation of the GDPR compliance. This will invite heavy fines and heavy penalties to the organization. Same way, if you see this one, when our viewer application directly invokes the customer's application, we get this response. The first name, last name, telephone number, email address, all these are sensitive fields which are shown in plain text, and hence a gross violation of GDPR. What we will now do is, for our solution, now we will look at the solution approach. For our solution approach, we will start up our Spring Cloud Gateway now. Okay, and then we will see what happens then. This is the fourth service we are starting up. Okay, so this service is started, and it started on port 8080. Now for our demo, what we will do is this one here. Now instead of calling this viewer service, calling the payment service directly, the viewer service will call the Spring Cloud Gateway, and Spring Cloud Gateway through its configuration and filters will then process the request and the response. So now we'll see what happens when we hit this. Yes, so what we see is that the response is still from the payment aggregator, but now this time all the sensitive fields that are of interest have been masked here. Same way, if you see this here, this is the viewer service calling the customer service, but through Spring Cloud Gateway, through the configuration of Spring Cloud Gateway, and we will see what happens. And here again, first name, last name, telephone number, and email address gets masked. Now let's talk about the other case also, where let's say GDPR introduces a new field, or let's say there is a change in the requirements, and we need to mask or not mask certain of these fields. Can we do that on the fly? Let's take a look at that. So for that, what we will do is we will there is a file here called I'm going into the Spring Cloud Gateway, and in here there is a file called sensitive data properties. Here we have listed all the fields. Let's say sensitive fields, we have said first name, last name, credit card number, telephone number, email address. Tomorrow, let's say a new field comes in, loan number. We simply will need to add it here, and on the fly the application will take that and implement the masking. So just to show that, let's say we have right now email address is getting masked. Okay, I want to show you how this works on the fly. Let's say we remove this email address, and I'm going to remove it from my local application. This is SpringCloudGateway. Yeah, and this is the file we're looking for. I'm simply going to remove this. Okay, we will see what is the effect of this. Right now email address is masked, and I have not changed anything, any code, just I have removed the field from the externalized file. That's it, and now this data shows up here. So we have, what we have done is, and reverse case, let's say we actually didn't have that masked earlier, but now GDPR has introduced that email address also should be part of this. We'll simply add email address there. I'm simply saving the file and I am running this, and on the fly our field gets masked. This is immense flexibility. This is immense flexibility that we have added to our architecture, and all through just configuration. We are not doing any code change here, and neither are we changing any of our core services, nor are we impacting any of our calling consumers. Thus we are solving this intricate problem in a very elegant way by simply going in a very in a configuration driven approach. Now let's go back to our Medium article here. So we have seen all this, and we are here at this stage. So what have we achieved? What have we achieved by introducing SpringCloudGateway into our architecture? Well, what we have achieved is that we have managed to solve this GDPR, this intricate GDPR problem with SpringCloudGateway. We have accomplished the goal within the strict timelines and the money constraints. Imagine if we hadn't done this approach, if we had to go through changing every single microservice, that would have taken an eternity. But here we are simply managing things just by configuration, and very, very rapidly. We have employed a configuration driven approach, thus added flexibility and extensibility to our entire approach. We were not required to change any code in the core services. None of the existing services were affected, and hence the testing, the manpower that would have otherwise been required has been extremely reduced. This SpringCloudGateway solution seamlessly caters to any future GDPR mandates, so that we already talked of. Tomorrow if they introduce more fields in that they consider sensitive, we only have to go ahead and add it to our externalized configuration file, and those will be picked up on the fly by the architecture, and those fields will get masked. So that's all I had for this discussion and this engineering solution. Thank you very much.